Okay, hi everyone, my name is Michal and I'm a computational lexicographer, which means I build software for dictionaries that includes dictionary writing systems and websites where dictionaries are published and many things in between. And I spend a lot of time sort of looking at dictionary schemas. And I've seen many dictionary schemas, and if there's one thing that they all have in common, I'd say it's that they tend to be overwhelmingly complex. So in my presentation today, I want to talk about one particular cause of complexity in dictionary schemas, which is the phenomenon of recursion or recursive embedding and various related phenomena. You have recursion in your dictionary if you have things like subsensing and subentrying, okay? Subsenses and subentries. If entries in your dictionary are allowed to contain other entries, or if, other senses, or if entries in your dictionary are allowed to contain sub-entries and so on, then you have recursive embedding. And the point I want to make in this presentation is that recursive embedding is a bad thing because it makes my job difficult. My job as a programmer, my job as an IT person whose job it is to process dictionary data, to write programs that process dictionary data. Having recursion in a dictionary is an unwelcome complication. It makes the job more complex. And so in my presentation today, I will be looking at things like subsensing and subentrying, and I will be discussing whether there are other ways to encode these things in dictionaries, ways that don't involve recursion, right? So another title for my presentation could be How to do subsenses and subentries without recursion. Before I go any further, I need to say that the ideas that I'm going to be presenting today are an interim result of various debates and discussions and thinking that has been going on in the OASIS Lexicographic Infrastructure Data Model and API Technical Committee, LexSIDMA for short. LexSIDMA is an organization which I'm a member of, and in LexSIDMA we're developing a standardized data model for a new generation of dictionaries. A new generation of dictionaries which are simultaneously human readable and easily processable by machines. So in LexSIDMA, it's very important for us that dictionaries are encoded in data structures which are relatively simple. And it is relatively easy and simple to write computer programs that read the dictionary data. So this drive towards simplicity will be a motivation behind the proposals I'm going to be making in this presentation. Okay, on to my first topic, which is subsensing. The second topic will be subentrying. So subsensing, as I said, you have subsensing in your dictionary if you have senses inside senses. So here's an example of an entry that has that. It's the noun work. You can see that it has a two-level sense hierarchy. There are top-level senses, and then inside them there are even more senses, right? And I haven't seen the schema for this dictionary, but it's possible that it allows even infinite embedding. Subsensing is usually enabled in dictionary schemas in one of two ways. One way to enable subsensing is through recursion. So the schema defines a data type such as sense, and it says that instances of sense can contain other instances of sense. This is recursion in the proper mathematical algorithmic sense, and it has this property that it can go on indefinitely, even though in practice dictionaries rarely go further down than 2 or 3 levels. And the other way in which a dictionary schema can enable subsensing is something I call soft recursion, or subsensing by subtyping. It works as follows. The schema says there are 2 data types, sense and subsense, and it says that instances of sense can contain instances of subsense. It's not, strictly speaking, it's not recursion, but it's a bit like recursion because it does allow some level of embedding. And in a typical dictionary schema, the sense and subsense data types are very similar in terms of the content they are allowed to contain, you know, definitions and examples and so on. So it's kind of a type of recursion, even though strictly speaking, mathematically it isn't. The point is that as a programmer, I dislike them both because they make my life more complicated. It's more complicated to write computer programs that process dictionary entries that have these things in them, right? Because you have to sort of crawl up and down the hierarchy all the time, and you have the same type of information at different levels of depths and so on. And writing recursive algorithms is generally more complex than non-recursive ones and so on. So what I want to do now is I want to propose an alternative way of encoding subsenses, an alternative way which doesn't use recursion, and it doesn't use subtyping, so it doesn't use soft recursion either. Right? It works something like this. You take your hierarchy of senses and you flatten it completely. So that's the first step. Don't worry, that's not the only step. You flatten it completely. So all senses are just children of entry. Then you give each entry a unique identifier. This can be generated by your dictionary writing system. And then in the places where one of the senses should appear as a subsense, you put in a special instruction that says, take sense ID so and so and put it here as a subsense, right? So what have we done? We have completely flattened the hierarchy, and we have changed the way we are encoding the sense to subsense relation. So instead of encoding the relation in such a way that we actually physically, explicitly stick the subsense in its proper place in the tree structure, we put it somewhere else, and we establish a relation that says this sense is a subsense of this other sense, and we use these unique identifiers for that. So we're doing something that looks a bit more like a relational database, but we're doing it in an otherwise tree-structured dictionary entry. What have we lost and what have we gained when we re-encoded the dictionary like this? We have gained and improved machine processability, or ease of machine readability. So for me as a programmer, it's now easier to write a computer program that just reads these entries and iterates through a flat list of senses instead of having to crawl up and down a recursive hierarchy of senses, right? So in terms of machine readability, this is an improvement. The disadvantage is that it's a little bit less legible for humans if the entry is encoded like this. So if you want to show the entry to a human end user, you need to do a bit of processing first. You need to actually reconstruct the hierarchy and move the senses to where they should appear as subsenses, and then show that to the human user. So it's a trade-off between machine readability and human readability. We can debate as to whether this trade-off is worth it or not, but in Lex Sigma, we have decided that we're going to take the needs of our machine clients a little bit more seriously, even if it means that we have to subtract a little from human readability. Just a little. The point here is that we're not losing any expressivity at all. We're still expressing perfectly well that the fact that this sense is a subsense of another sense. We're just doing it differently, right? So that's my proposal for subsensing. Now let's move on to sub-entrying. I said you have sub-entrying in your dictionary if you allow entries inside entries. So here's an example of a very short entry that has that. The entry for the word Bible. It has two senses, and the first sense is actually a sub-entry because it kind of has its own head word, right? It's headed by the expression the Bible. And what sub-entries do in a dictionary is that when you're reading the entry from top to bottom, it suddenly changes the object of what you're reading about, the object of description, okay? So you're reading the entry from top to bottom, and this is an entry about the word Bible. But then you reach this sense, and suddenly what you're reading about changes. You're no longer reading data about the word Bible, you're reading data about the expression the Bible, right? And then the sense ends, you emerge out of that and go on to the next sense, and then the object of description changes back to what it was. So now the second sense is about the word Bible, the head word of the whole entry, okay? So the object of description changes, and then it changes back as you're reading through the entry. So what sub-entries do is they override the head word. So this phenomenon of head word overriding is important here. Normally in a dictionary entry, everything inside the entry is about the head word, but sub entries change that. They override the head word. And that's a complication for somebody like me who's writing a computer program which needs to process dictionary entries and maybe just collect usage examples or definitions of things. As my computer program is iterating through the senses of the entry, it needs to keep track of what the object of description is. It cannot assume that the object of description is always the head word, because it can be overridden by a sub-entry somewhere deep in the entry. Okay, so that's a complication for me as a computer programmer, and ideally I would like sub-entries to be encoded differently so that I don't have to write programs that need to keep track of what the object of description is. Okay, so ideally I would like to be able to assume that when I'm reading an entry, the object of description is always the same. It's the head word, no exceptions, right? So my proposal for encoding sub-entries differently is as follows. We begin by just taking the sub-entry and promoting it to the status of a totally independent entry. So we create two separate entries, one for the word Bible and one for the expression the Bible, right? Step number one. Then we give each entry a unique identifier. Again, this can be generated automatically by the dictionary writing system. And finally, in the place where one of the entries should appear as a sub-entry, we put in a special instruction that says insert entry so-and-so here as a sub-entry, okay? So again, what have we done? We have kind of flattened the structure. We have removed any necessity for changing the object of description as you're reading down an entry. And we have changed the way we encode the entry to sub-entry relation. Instead of actually having the sub-entry physically, explicitly in there in the tree structure of its mother entry somewhere, we have it somewhere else, and we have created a relation that says this entry is a sub-entry of this other entry. Okay, so we're encoding the same facts. We're not losing any expressivity. We're just doing it a little differently. What have we gained? We have gained machine readability. We have gained the ease with which somebody like me can write a computer program that can process this entry, because I can always assume that the object of description in each entry is always the same. There will never be any headword overriding. On the other hand, we have lost a bit on the human legibility scale, because the entries are now again a little bit less human legible. So if you want to show these entries, if you want to show the entry for Bible to a human user, it would be a good idea to do a bit of processing first and to reconstruct the hierarchy first, and then show the entry to the human user. So again, it's a trade-off, and in Lex Sigma, we have decided that we are going to prefer this relational remodeling of recursion and recursion-like things, because it makes the dictionaries more easily machine processable, even though it has some sort of disadvantages for human readability. Okay, those have been my two proposals for re-encoding sub-entries and subsenses. So just to summarize, what we've done is we've taken these things that traditionally are encoded in dictionary schemas through various kinds of recursive embedding, where you have objects of some type inside objects of more or less the same type, and we have kind of remodeled them as relations like you would have in a typical relational database, right? We are gaining some advantages, simpler readability, easier machine readability, and the schemas generally tends to be simpler because there are fewer types in them. On the other hand, we're losing some human legibility. In Lex Sigma, we are prepared for that. We think it's a trade-off which is worth it. Right, and that brings us to sort of the conclusion of my talk. I hope you believe me when I say that recursion and subtyping and headword overriding, when they occur in a dictionary, they make life difficult for programmers like me. It makes it more difficult to write programs that process dictionary data. And I hope I have convinced you that there are other ways of encoding these things, sub-entering and subsensing, ways which do not require recursion or headword overriding. And I would like to say for the next dictionary project that I work on, if they ever let me near one again, I hope that it will be encoded like this.